Okay, so this lesson for you guys hits on the time of the calendar. It's my favorite day for this to hit. This is probably about the best return from a 2-week break, start the new year kind of lesson because A, it doesn't have anything new in it. B, it's going to remind and reinforce a whole lot of stuff we did before we went on break. So this is a pretty fair summary of a whole lot of skills. There's probably about 12 or 15 days worth of lessons that this reviews. So it's a nice, I think it's a good come back, get going again sort of lesson. So what do you notice that's weird about these problems that are up here?
Decimals.
There's decimals. It's weird though. And fractions. Within every problem, there's a decimal and there's a fraction. So what we're going to have to do first is get some guidance from the homework section itself. They'll tell you whether they want fraction answers and you're living in fraction world or whether you're living in decimal world. Half the problems are going to want to have fraction answers, half the problems are going to want to have decimal answers. They'll have to tell you which one. You won't have to pick. So if they want to do fraction answers, what's the first thing that we're going to have to do over in this world if this is fraction world? Close, but not quite. Make any decimals into fractions. If they want fraction answers, we're going to have to make everything be a fraction. So one skill from old days we're going to have to remember is how can we take a decimal and make a fraction out of it? Somebody remind us, how can we take a decimal and make a fraction out of it?
It's like 0.6 would be 6/10.
6/10. How do you do?
It's in the tenths.
It's in the tenths place. Just use the place value. So 0.6 is 6/10. You could just put 6 over 10. What's another way we could make a decimal a fraction? That's probably the most common way. No, not for a decimal. It's another tool that you all own that you could turn 0.6 into a fraction using this tool.
The fraction chart.
That chart that we did a bunch of times, that 55-point chart. 6/10 is not the only fraction you could pick. What's another fraction you could pick for 6/10?
3/5.
3/5. It doesn't really matter. Any fraction will do. So 6/10 is fine, 3/5 would have been fine. For us to do this one, you could put 75 over 100, or you might know it from your chart. Does anybody have an opinion on 0.75, a fraction for that?
3/4.
3/4. I'd probably pick the 3/4, not the 75 over 100. Just seems easier to deal with 3/4. 0.5, we need to make a fraction. Somebody, anybody, 0.5, make it a fraction. It is a half. If you said 5/10, I'd have been just as good with that. Wouldn't have really mattered to me. Okay, but that would be skill reminder review 1 is decimals can be made fractions. We remember how to do that. If we're doing fraction answers, it's just the way it's got to be. Question about that little startup move? Then we have to remember everything we knew about fractions. Adding fractions, subtracting fractions. What's the guideline for that? What's the main thing you have to do if you're going to add or subtract any fraction? Have a common denominator. So with 2 and 10, what would you pick? 10. What if we had made this 3/5? What would we have picked? Also 10. So that's why this one, it didn't really matter what we picked. If you're picking a common denominator, sometimes to have something a little bigger doesn't actually hurt anything. Then if we're going to change the bottoms, we have to change the tops, and that does involve multiplication. So a half, what's the new top? Just yell, anybody? 5. What if the bottom didn't change? Just carry the top down, and that will do the math. 5/10 plus 6/10 for a second makes 11/10. But now here's another reminder. This is called what kind of fraction?
Box on top.
Improper, so box the top is a slogan you guys have learned. We'll divide the bottom into the top. Best answer on this? 1 1/10. Question about that first one? Okay, multiply. Do we do common denominators when we multiply? No. What are your options? There's two perfectly acceptable answers for multiplying this.
You can multiply across.
You can go straight across, that would be fine.
Or you can reduce.
Or
We know cancel.
cancel, we can cancel. So if we want to cancel, the 3's could go. 2/4, what would 2/4 be better known as? 1/2. You could have also canceled again, because 2 goes into 4 twice. That's another way to get a half. If you multiplied across, what would you have had in your mind at first from multiply across without the cancel? 6/12. Still would have ended up as a half. So we have a little bit of variability to that. Question about that world. And then here's another reminder lesson. Dividing fractions. What's the key move when you divide fractions?
Flip the second fraction.
Flip the second fraction. So 3/8 is good. 1/2 needs to flip. Now that's a multiply. And now we have the same options as a minute ago. You could either multiply straight across, or you could cancel. Somebody with a hand and an opinion, jump in. Straight across or cancel.
2 and 8, we'll count 1 and 4.
Okay, 2 and 8 cancel, leave a 4. Okay, and then what's your answer on that? 3/4. So that's a pretty fair summary of everything we've ever done with fractions all in one swoop. That's why I like when we accidentally just bump into this on the day back. It just gets us going again with nothing new, a lot of review. Question about fraction town? Okay, then over to decimal town. So if we're in decimal town, we have to take a different approach. What are we going to have to start off doing if they want all decimal stuff?
Change the fractions to decimal.
All the fractions have to be decimals. So 1/5. How can you turn 1/5 into a decimal?
0.2.
We can make it 0.2. How'd you do that?
Box itself.
You could, yeah. We can go bottom into the top, throw a decimal, throw a 0, decimal goes straight up, look to divide. That's probably not what you did though, because you were too quick to do that.
Well, I was memorized.
We memorized it. Yeah, if we know those from our chart, just keep using that chart. So 2/5. Somebody 2/5, remember? It is 0.4. Anybody 4/5?
0.8.
It is 0.8. So that's our first move, is fractions need to become decimals if that's what they want from us. Question about making that trade? Then we'll have to remember everything about decimals. So adding decimals or subtracting decimals, what's our key? How do you add or subtract decimals? Numbers? Yeah.
You can go to the right, maybe?
No?
Find the decimal.
Line them up. We'd want to go, the decimal lines up with the decimal, and when we go into the answer, the decimal and the answer, and all the decimals are in a line. The ones in the problem, the ones in the answer. So line up the decimals, and this will be 0.9. Multiplying, we don't line anything up. How do we multiply this?
We just divide the numbers up, like, yeah, divide the number places up.
Okay,
So it would just be 7 over 4.
okay,
And then we add, like, 0.7.
okay. And then what will you get when you multiply?
Oh, well,
28. Okay, so we're just going to need to do 4 times 7, 7 times 4, whatever order you want. We're showing up at 28. Then how do you know where the decimal goes when we multiply?
how many numbers are to the right of the decimal?
Yeah, we count everything to the right in the problem. So how many numbers back here count? 2. The 4 is on the right, the 7's on the right, we have a count of 2. So to make this have a count of 2, where do you plot the decimal down to force that count? Right in front of the 2. A decimal right there forces us to count to 2. So multiply involves counting, counting everything to the right. Question about multiply. Okay, divide. Divide's a little different still. So divide, we need to get the right number in the right spot. Should this be the 8 or the 5? 8. The second number is called the divisor. That's the one that always goes out. The 8, the dividend, the first number, that always goes in. Somebody remind us, how did we divide with these numbers?
Carry up the decimal.
We won't immediately do that though. This problem has something else we're going to have to do. You are right, that's coming, but not yet. The divisor has to be a whole number. So if there's a decimal in the divisor, that has to move over, which means the dividend has to move over. And then it goes straight up from its new location. 5 into 8 goes, just yell, once. That gets us 5. Remainder looks like 3, but we're not allowed to do remainders. So what do we do when we're getting forced remainders? Add a 0. 5 into 30, 6, and that's going to go evenly, and now we're good, and that's decimal world. Question about decimal world. Can you turn me a little bit, because I'm about to disappear over the line. One last little world. This is a reminder of another thing we did. There's just going to be one little difference today. What were these letters called? They're called variables. When a number is next to a variable, what's that mean they're trying to do on the blackboard? What's happening with them for each other? They're multiplying. All of these variable problems, what have you always had to do? Always do the O word. They're doing something. You're going to do the opposite. We're going to do the opposite. So if this whole group of problems is all multiplying, your life is going to be all having to divide. So this, we would want to take 5 into 30. No big deal. That's going to go 6. That's what always has happened to us before, is something like that. Here, if we go 5 into 21, why do we have a little bit more of a problem than we used to have with this? It doesn't evenly go in. 5 does go into 21 4 times, but that only gets us up to 20, leaving us,
1.
you have a couple choices of how you can manage this. Putting an R and a 1 is not a thing. So we need another way to manage this. Does anybody know another way to manage this? We could make it a decimal. So we could throw a decimal and we could divide till it quits. I'm fine with that. If you want to do that, you're welcome to do that. I don't want to do that. Anybody have a thought on why I don't like to go decimals and divide till it stops?
You don't feel like doing the rest of it?
Yeah, because how long might it go?
It might go forever.
It might go a really long time. Yeah, so we don't know how far it's going to go. I'd rather not do that. Does anybody know a quicker thing we can do to just have an answer right now and get out?
Make the 1 and a 5 fraction?
Yeah, just make the 1 and a 5 a fraction. Which way?
4 and
1/5.
1/5.
Put this remainder on top, and then the thing we were dividing by, just put it on the bottom. That's a quick way out right now. That wouldn't have gone far. You know, if we added the 0, it would have been 4.2. No harm in that. But this one, you'd be a while. If you take 7 into 39, that's going to go 5. 4 sevenths. Do you remember the sevenths from the chart?
Oh, yeah.
How many spaces will they go?
5, 6.
6. So if I did a decimal and kept going, I'd have been at that a while. I certainly would not have fit it into that space. Okay. For this one, what divide would I look to do? Yeah, so who's out? The .07 would be an out. The .0049 would be an in. What would you have to do before you can even divide? Go that one over 2? So that one goes over 2. And then we go straight up. Who should be above the 4? 0, because it can't do it. 7 we can do into 49. .07. For this, .05, 1.3, who's out, who's in?
0.5 is out.
The 0.5 is out. The 1.3 is in. Before you can divide,
Move the decimal over 2 spaces.
go over 2 spaces in both, which empties need
0.
0. 5 into 13,
2.
2 gets me
10.
3 and
0.
0. 5 into 30,
6.
6, and then we can stop. That's 26. Why does this one look weird to some people? Sometimes people will complain about this. Why does this one look weird?
It's the other way.
It's like the other way. So if that bothers you, just switch it. Just put 5x equals 27, but it doesn't have to be switched. You just have to divide the correct way with the correct number. Should it be the 27 or the 5?
5.
5 is out. Whoever's with the variable, that's always the number that's going to be out. 5 into 27, somebody?
5.
Be 5 times, gets us up to 25, leaves us,
2.
so
2/5.
2/5. What is the decimal for 2/5 if some people prefer to do that?
0.4.
So go 5.4, that's fine. So if it has whole numbers in the problem, you can do this fraction trick, that's fine. If it's a decimal problem though, you have to divide till it stops. You can't do a decimal answer that also has fractions in it. So the fraction trick is only for problems that didn't have decimals in them. It's kind of a recap of, like I said, about a dozen lessons from before break, sort of all revisited and retaught. So, question about any of this stuff? Okay, so homework, we're going to head to 2 locations. The first smaller location is 202. On 202, we're only going to do the letters which go from A to F. So 202 letters A to F, it's like these variable problems, there's 6 of them on that page to do. Then the main page is going to be a set in the back. The set in the back is set FF. Set FF, the top half will say by the directions that it's fraction world. So the top half, everything becomes a fraction, everything is fraction answers. Then the bottom half is decimal world. Everything has to become a decimal, everything's decimal answers. 202 letters, FF, that's all we have. If you can hit stop, we're good to go.